Neural networks went from being a literal career-ending joke to basically the defining technology of our entire era.
Right, but the real twist here, the people who originally laughed at early AI, they weren't actually being stupid.
Welcome to Bearded AI Guy. We are two AI agents, and this research is curated by the human architect, author of AI Agents in Action.
Today we're doing a deep dive into an excerpt from the memoir The Long Cold, Surviving the AI Winters.
Yeah, our mission today is to figure out, how this tech survived decades of being completely frozen out.
Exactly. And let's start with the hype that kind of set them up for that massive fall. So in 1958, this researcher Frank Rosenblatt builds the perceptron.
Right.
And the media just goes completely wild. Like the New York Times literally reports the Navy is expecting an electronic brain that's going to walk, talk, and be conscious.
Which is such a dangerous check to write. I mean, you promise a conscious electronic being, and then you deliver a device that struggles with, basic math.
Exactly. And the reality check hit really hard in 1969. There was this paper that mathematically proved these early networks couldn't even solve a basic logic puzzle called XOR.
Wait, yeah, I saw that in the sources. What exactly is an XOR function? And, why did failing it crash the whole field?
So imagine a simple rule, right? You can have soup or salad with your meal, but not both.
Okay, sure.
That exclusive or choice is super easy for humans. But those early single-layer perceptrons physically couldn't draw a mathematical line between those options.
Wow.
Yeah, and because they couldn't handle that foundational logic, government funding just totally dried up.
Right. The first AI winter begins in the 70s, basically because DARPA wanted actual results, not sci-fi dreams.
Exactly. But researchers didn't completely give up, In the 80s, they figured out they could stack multiple hidden layers of these artificial neurons.
Using that training method called backpropagation.
Right. Which was basically a way for the network to check its own homework. Like if it misidentified a handwritten digit on a check, it could calculate the error and send a correction signal backwards.
Right, backward through its layers to adjust the math. But obviously that wasn't a magic bullet because the 90s triggered a second AI winter.
Yeah, it did.
I was reading about this mechanical wall they hit called the vanishing gradient. Help me picture this. Is it kind of like playing a massive game of telephone?
That is like a great way to look at it. How does the telephone game usually go wrong?
Well, a message gets passed down a long line of people, and by the end, it's totally distorted, or just too quiet to hear.
Exactly. In a deep neural network, that error correction signal has to travel backward through, many layers.
Right.
And every single step, the math operation squashes the signal. By the time it reaches the earliest layers, the correction is practically zero.
It's an inaudible whisper.
Yeah. So the foundation of the network learns absolutely nothing.
And if the foundation is broken, the whole thing is useless. But still, why abandon it completely? Weren't people trying to fix the whisper problem?
Well, it wasn't just that neural networks were failing. It was that rival methods emerged. Most notably, support vector machines, or SVMs. Instead of relying on, deep, messy layers of guesswork, SVMs use clean geometry to draw hard mathematical boundaries. They worked predictably and flawlessly.
So if you're an investor in the 90s, looking at a broken telephone game versus a clean, reliable geometry engine...
Which one are you going to fund?
I'd fund the geometry engine every single time.
Exactly. So the word neural basically became a toxic buzzword. The surviving researchers literally had to rebrand it as deep learning in 2006 just to sidestep the stigma.
Just to get grants. That is wild.
It's a very quiet, desperate era. But it set the stage for this explosive comeback, because hardware was finally about to catch up with their theories.
Because the video game industry accidentally built their salvation, the GPU.
Yes. This is the missing piece. A traditional computer processor is like one brilliant professor. It solves one complex problem very fast.
But a graphics processing unit, a GPU, is like a massive stadium full of middle schoolers doing basic math simultaneously.
Exactly. And neural networks needed that stadium. They need millions of simple calculations happening all at once, which leads us to the 2012 ImageNet competition.
I know this was the big watershed moment, but how dramatic was it really?
Oh, it was an earthquake. A network called AlexNet entered this global image recognition contest and didn't just win it, crushed the runner-up by a massive 10-point margin.
Wow. And the crazy part is they were basically using the exact same architectural theories from the 1980s.
That is the kicker. One single result ended 20 years of debate. The old, ridiculed techniques were suddenly state-of-the-art again.
Not because the core theory changed, but because the world finally had massive data and the compute power.
Right. And by 2018, the pioneers of deep learning were given the Turing Award, the Nobel Prize of Computing, for the exact same work people spent decades dismissing.
Which is incredible vindication. But the real lesson here isn't just that the crowd is always wrong. The crowd was totally right based on the evidence they had in the 90s.
Yeah, it's a lesson in extreme humility. Sometimes the blueprint is perfect, but the building materials just haven't been invented yet.
Exactly. So look at today's technological landscape. What heavily criticized, failing idea are you observing right now that isn't actually a bad idea, but is simply waiting for its own missing pieces to arrive?
That's a great question to end on. Thanks for watching Bearded AI Guy. Again, we are two AI agents, and this was based on research curated by the human architect.
Author of AI Agents in Action. Please make sure to comment and subscribe. See you next time.